Why are animals that originally weren't crabs slowly evolving to look more and more like crabs? You heard that right. Many wild animals that have nothing to do with crabs have, over millions of years, independently evolved toward a crab-like form. Look here. This isn't a crab. This isn't a crab either. In fact, none of the creatures you're seeing are crabs, yet they're all moving in the same evolutionary direction. Scientists even have an official name for this strange phenomenon: carcinization or crabification. From a scientific perspective, this is actually convergent evolution at work. Simply put, when different species face similar survival challenges, they often evolve the same useful traits. Just like giant squids, two unrelated species both evolved huge bodies because being large helps them survive and hunt. So why do so many species end up becoming crab-like? To answer that, we first need to understand what crabification really is, because not everything that looks like a crab is a true crab. Most crab-like creatures are evolutionary imposters. They just happen to end up looking like crabs. A crab's body is wide and flat, a structure that lowers its center of gravity, keeps it stable, and allows it to squeeze into rock crevices to hide from predators and strong waves. Nobody wants to get flipped over by the sea. Crabs also have hard shells, not just armor, but a compact, mobile tank. Their legs are short and powerful, giving them precise movement and excellent sideways mobility. Moving sideways helps them keep their claws and eyes facing danger at all times. This leads to an interesting question. If the crab shape is so efficient, why doesn't everything evolve into lobsters instead? Lobsters are also strong, armored, and successful. Yet there's no such thing as lobsterification. The problem lies in the lobster body plan. Lobsters have long, segmented bodies and big tails. To compress that into a crab-like shape would require completely redesigning their entire structure, an evolutionarily expensive process. Crabs, on the other hand, have simpler, more flexible bodies that can adapt quickly to different environments. In short, crabification is easy. Lobsterification costs too much. So who was the first creature to truly crabify? The earliest true crabs, deep-sea crabs, appeared more than 200 million years ago, even before dinosaurs. But they weren't the only ones evolving in that direction. Around the same period, some crustaceans that weren't related to crabs also started developing crab-like features. Early scientists labeled some creatures as true crabs simply because they looked flat, wide, tail-tucked, and walked sideways, long before genetics or evolutionary history were understood. One of the most famous imposters is the king crab. Genetically, king crabs are descended from hermit crabs, the little beach creatures that burrow snail shells. Over millions of years, they grew their own solid exoskeleton, stopped relying on borrowed shells, flattened their bodies, and eventually evolved into a crab-like form. Even though king crabs look nearly identical to true crabs, their genetic relationship is completely different. That's also why they taste different, because at their core, they're not the same animal. Then there's the porcelain crab. Despite the name, it's closer to squat lobsters than to crabs. Its shell is delicate and almost porcelain-like, but to early explorers, anything that looked like a crab was simply called a crab. Crabification even happened before true crabs existed. Fossils of ancient proto-crabs show that long before actual crabs appeared, some species were already evolving wide, flat bodies with tucked-in tails, as if evolution itself kept reinventing the crab shape again and again. But if crabs are such perfect designs, why did so many early almost crabs go extinct? Mostly because their crabification wasn't complete. Some lacked hard shells and were outcompeted by true crabs. Some didn't have stable, sideways walking legs. Others disappeared during mass extinction events like asteroid impacts. Even so, evolution continued producing new crab-like forms. The physical laws of the world make the crab-like structure an efficient survival solution for many crustaceans, so it reappears repeatedly. Modern crabs are simply the most successful versions so far. So who will become the next crab? Surprisingly, under the right conditions, almost any crustacean with the right potential could evolve that way. Some shrimp species already show early signs, like flattened tails, the first step toward crabification. But don't worry, crabification mainly affects crustaceans. Humans aren't turning into crabs anytime soon. Still, some non-crustacean animals also evolve similar shapes due to similar survival needs. For example, porgyfish have a wide, flat body to stay stable on the seafloor, similar to how crabs flatten themselves to resist strong currents. This kind of partial convergent evolution is everywhere. Dolphins and sharks, one a warm-blooded mammal, the other an ancient fish, both evolved streamlined bodies because that's the most efficient design for fast swimming. Birds, bats, insects, and even some dinosaurs all developed similar flight structures because physics only allows a few effective ways to fly. So no, not all animals are destined to become crabs. The crab form is just one of nature's clever, efficient solutions that evolution keeps returning to. So who becomes the next crab? Only time will tell. If you enjoy topics like this, hit follow and join me as we explore more fascinating stories from the natural world.